Hey guys, we are going to go back in and we're going to do this next problem. Okay, so this problem we have to list all the rational zeros that are possible according to the rational zero theorem. So we got to have all the factors of 175 over the factors of 3. So that's what we're going to do. We're going to list all the factors of 175. So we've got positive and negative 1, positive and negative 5, and it's 5 times 35. And then we've got positive and negative 7, and 7 times 25, and 175. So those are all the factors of 175. And then the factors of 3 are positive negative 1 and positive negative 3. Okay, so now those are the factors. Now what I'm going to do is I'm going to create fractions, and that's where the answers come from. So obviously 1 over 1 is just 1. 5 over 1 is just 5. 7 over 1. 25. And 35. And 175. Okay. And then we do the fractions. Okay. Now this would be 1 over 3. So that's 1/3. 5 over 3. 7 over 3. 25 over 3. 35 over 3. And 175 over 3. And these are also all positives and negatives. These are possible answers. Now, if you'll look closely, you'll see that this matches answer choice A. Matches answer choice A. Look closely. B does not have 5 as a factor and has 3 as a factor. It has it flipped. It's the factors of the last number over factors of the first number. So B has them flipped, so B is wrong. C has 10 as a factor, and 10 is not a factor of 175, so that's wrong. And again, D has them flipped. It has the 3 on top and the 175 on the bottom, and that's wrong. So you know it's not B or D because they're flipped. C has a factor of 10 in there. That's not right. So your answer is choice A for this one. So those are our first part. So answer choice A. And then this next part says use synthetic division to test several possible rational zeros in order to identify one actual zero. So this is where I'm actually going to start dividing. And I have 3, negative 7, negative 75, and 175. And then I'm going to pick a number from my list. I'm going to do positive and negative 1. So I'll do that real quick. See if 1 works. 1 times 3 is 3. And then negative 4. No, this is not working. I'm supposed to get 0. So 1 did not work. So let's try negative 1. Let's see if that works. So that would mean negative 3. So that's negative 10, positive 10, negative 65, and then positive 65. Nope, that's not working. All right, so now I'm going to try 5 and negative 5. Or just 5. I'm not going to do both of them. Well, I might do both of them, but try one at a time. Okay, so I'll do 5. So that's 15, and that's 8, and that's going to be 40, and that's going to be 35. That's negative 30. Oh, I get a winner. Yay! 5 worked. Yay. So that is one of my answers. So that's going to go in this blank right here where it says one answer is 5. Okay, so 5 worked. 5 worked. So now what do? Now I'm going to take these 3 and I'm going to use my quadratic formula or factoring. If it'll factor, it looks pretty big. I think I'm going to use quadratic formula to get my other answers. So here we go, quadratic formula. So this is 3x squared plus 8x minus 35. I'm going to set it equals 0, so negative b plus or minus the square root b squared minus 4 times a times c all over 2 times a. Let's get that radical done. That's going to be 64 plus something. Calculator. 420. And this is the square root of 484. And that is 22. It is a perfect square. That means I could have factored it. So now let's take it back into the problem. So negative 8 plus or minus 22 over 6. All right, so that's negative 8 plus 22 over 6. So let's see what that is. That's 14 over 6, which reduces to 7 over 3. That's one of my answers. Now, hey, look, that's in my list. Go back and look at your list. 7 over 3 is in my list. All right, then I'm going to do negative 8 minus 22 over 6. That's negative 30 over 6. That's negative 5. That one's also in my list. I have 3 answers. They are 7 over 3, 5, and negative 5. And it does not matter the order you put them in. Let me just show them to you again. The first one was 5 because we got the using 0. The second one was 7 over 3. And the third one was negative 5. So those are my answers. Okay, so now let's look at that problem one more time. That's a long problem. We do our list with our factors. We synthetic divide till we find 1. Then we use the quadratic formula to find the other 2. If you are lucky, you can guess on the synthetic division and not actually have to do 3 go-arounds, because you just got to guess the right one. And if you have a lucky guess, hint, hint, there you go. All right. It's just math, y'all. Don't have my thumbnail ready, but keep pushing.